Alright, I thought I'd make you a short video of using logs. Um, uh, so we'll do expanding a log. So let's take a look at this one. We have log of x squared cube root of x plus 2 divided by x squared minus 25. So what's going to happen here first is we're going to use the quotient rule, and we're going to break that up into log of x squared times the cube root of x plus 2 minus log of x minus 5, x plus 5. We're going to go ahead and factor that difference of squares in the denominator there. So here we go, log of x squared, x cubed plus x cube root of x plus 2, and then minus log of x minus 5, x plus 5, and that's using the quotient rule. Then we'll go ahead and use the product rule and split up the x squared and the cube root of x plus 2. Also, we're going to go ahead and rewrite that cube root as a 1/3 power, so we can go ahead and use the power rule in a later step. We're also going to use the product rule on the log of x minus 5, x plus 5, and we have to distribute that minus sign through, so you need to be careful about that. So log of x minus 5, log of x plus 5. Okay, and that's using the product rule. And then finally we're going to use that quotient rule, or not the quotient, the power rule to bring down those exponents. So 2 log x plus 1/3 log x plus 2 minus log of x minus 5 minus log of x plus 5, and that's using the product rule. So there's our final answer using the quotient rule, product rule, and power rule. Alright, now we're going to use log rules to condense. We're going to condense down into a single logarithm. So we have 1/5 log t minus log 7 minus 2 log x plus 2. So the first thing we're going to do is we're going to go ahead and use the power rule to put the 1/5 back up on the t. That'll be a 5th root of t, and we'll bring that 2 back up to make that an x plus 2 on that last term. So we have log 5th root of t minus log 7 minus log of x plus 2 quantity squared. And that was using the power rule twice. Now what we'll go ahead and do is we will go ahead and combine the first two using the quotient rule. So log 5th root of t minus log of 7 can be combined using the quotient rule to be log 5th root of t divided by 7. And then we'll use the quotient rule one more time to get that remaining x plus 2. That's going to be in the denominator, so it's going to sit right next to the 7 there. So using the quotient rule, and then use the quotient rule one more time, so that x plus 2 quantity squared goes in the denominator. And this time we use power rule, quotient rule, and the quotient rule a second time. Okay. Now we're going to look at a couple examples of solving log equations. So log of x plus 7 equals log of, I think that's a 2. Okay, it is log 2. One thing we need to be careful about is at some point in time we need to make sure that when we do get an answer, it is within the domain. So remember, the domain of logarithms is greater than 0. So we need to set x plus 7 greater than 0. That gives us the requirement that x is greater than -7. Since logarithms are 1-to-1, that means I can go ahead and equate the inputs. So I have inputs of x plus 7 and an input of 2, and they're giving me the same output. That means the inputs have to be the same. Alright, so that since the log is 1-to-1, and we get x is equal to -5. And that checks out just fine with the requirement. So let's do another example here. We got log of x plus log of x plus 15 is equal to 2. Since this is just regular log, you don't see the base, but the base is understood to be 10. In order to solve log equations, you're either going to have a log equals a log, and they have to have the same base. Then you can equate the stuff inside the logarithms, the arguments. If there's multiple logs, then what you might want to do, or what you need to do in order to solve it, is combine them. and that's where we would want to practice condensing. So I'm going to use the product rule here and condense the log x and log x plus 15 to be log of x squared plus 15x equals 2. And I'm going to make a comment here about we use the product rule. And then we're going to use the definition of log. So the base on the log is understood to be 10, so it's 10 to the second power is equal to the argument inside the log. So we have 10 squared is equal to x squared plus 15x. And that is definition of log. And then I'll make a note here, log of x is the same thing as log base 10 of x. So we're going to solve a quadratic here, so we're going to move everything to one side, set it equal to 0, and hope that it factors. So we have x squared plus 15x minus 100. Remember, 10 squared is 100. That's going to be equal to 0. This factors into x plus 20 and x minus 5 equals to 0. Solving this, we will get x minus 20, x equals minus 20, and x equals positive 5. I forgot to mention my domain at the beginning, so we'll mention that here at the end here to check our answers. So we get x is equal to negative 20 or x is equal to 5. Now I have these two requirements here. Oops, let's see if we can go back here. So I have these two requirements here. One of them is x has got to be greater than 0 because of just the log x. The x has to be greater than 0. The other requirement is log of x plus 15. The x plus 15 has to be greater than 0. So we have x is greater than 0 and x is greater than negative 15. And the x is greater than 0 is more restrictive. So what that's going to force us to do is we're going to have to cancel that negative 20. That's not going to be a good solution. It's going to be an extraneous solution. But the 5 works. The 5 will be our answer in this case. Okay. Now let's go ahead and I think I have two more. So let's look at solving exponential. So we have 8 to the negative x is equal to 1.2. I'm going to go ahead and rewrite it just so I have a little bit more space. And since we're solving for an exponent, the inverse of exponentials are logarithms. So what we're going to do is we're going to take the log of both sides. Kind of similar to squaring both sides, adding something the same number to both sides, subtracting the same number to both sides. It's a valid operation we can do to both sides. The 8 to the minus x, the 1.2 are never 0 or negative, so we're okay with that too. They're both within the domain of the log. And then the power rule is going to bring that minus x down. And we have negative x log 8 equals log 1.2. We can go ahead and divide both sides by negative log 8 because I want just x, not negative x. So we'll mention that we use the power rule there and divide both sides by negative log 8. X is equal to log 1.2 over log 8 with a negative sign, and that is approximately equal to negative 0.0877. I think kind of the general rule of thumb that we've been doing is just rounding it to about 4 decimal places would be good. Alright, one more. So let's say we have 2 to the x equals 5 to the x minus 2. Again, we're trying to solve for exponents, and the way to undo the exponential is to take the log of both sides. You could also use the natural log. You'll get the same answer. But either one will work just fine. So the power rule is going to bring down both those exponents. So x plus 1 times log 2 equals 1 minus 2x log 5. Okay. Now this is just a regular algebra problem. It's just got those funky looking logs in there. But we're going to go ahead and use the distributive property on both sides. So that's what's going to happen here. So x log 2 plus log 2 equals log 5 minus 2x log 5, and that was using the distributive property. Okay, now what we want to do is we want all the x's on one side and all the numbers on the other side. So we're going to go ahead and we're going to add 2x log 5 to both sides of the equation, and then at the same time we're going to go ahead and subtract log 2 from both sides. So that's what's going on here. We're solving for x. We're moving all the x's over to the left hand side and the numbers onto the right hand side. Okay, So rewriting, we have x log 2 plus 2x log 5 equals log 5 minus log 2. Okay. On the left-hand side, everything has an x in common, so we're going to go ahead and we're going to factor an x out. So that'll be x log 2 plus 2 log 5, and that's going to be equal to log 5 minus log 2. Okay, and I'll mention that we're factoring out an x. And the last step that we're doing here is we're going to divide by log 2 plus 2 log 5. It's just a number, we just don't know what it is. But that's the last step we're going to do there. So we go ahead, factor out the x, and then we're going to divide. Okay, so we got log 5 minus log 2 divided by log 2 plus 2 log 5, and punching that in the calculator, rounding to 4 decimal places, we get 0.2342. Well, I hope this was helpful.